Hello everyone, it's Mr. Christie with a question from Corpio Maths. My students asked me this today. It was about working out the maximum minimum argument given a particular kind of problem involving loci. So the first thing I'm going to do, the question says the modulus of z minus 3 minus 4i is equal to 2, and then we've got a bunch of questions. Now before I start this question, or the series of questions I have here, I'm going to first sketch the modulus of z minus 3 minus 4i equals 2. Now, the way I'm going to do that is, first of all, I'm going to find the center. Now, I don't need to get the Cartesian equation for this, but it's a circle, and I can convert it if I need to, if they ask me to. But the way I'm going to do this is, I'm just going to switch the signs here. So 3, 4 is the center, right? So we're going to use the Argand diagram. Okay, this is my real axis. This is my imaginary axis. And I have 3, 4. And the distance of the center from the origin is 5, and I did that on purpose. I'm now going to have a radius of 2. So here's 1. I know it's not perfect scaling, but let's say 1 here, 5 here, 2 here, 6 here. Best as I can. Okay. All right. Find the maximum argument. Now, the way you want to think about this is, so z, what is z? It's any complex number that satisfies this equation. So it's any point on the circumference. So which point on the circumference, or which complex number, complex number, we can use them synonymously here, which of these would give me the maximum argument? The way you should think about this is, okay, we're measuring the argument, and by the way, perhaps I should say the argument is between, let's say theta is between minus pi. And the way I should think about this is, the argument's increasing, right? We measure it anti-clockwise. And then there's a certain point, which is when I'm a tangent to the circle, where I get the maximum argument. So what I'm going to do is draw that line. I won't use the ruler because it's quite far away. But what I'm going to do is draw that line. Okay. And then I have to work out a bunch of angles. Okay, so there's that line. And what I'm going to do is, well, that's a tangent. Immediately I'm thinking about circle theorems. I'm going to draw tangent meets the radius at 90 degrees like this. And I'm going to draw a line like this. And this angle I can actually work out. Let's call that angle alpha. How would I get alpha? Well, the radius is 2. And I can work out this length here, the hypotenuse, by doing 3 squared plus 4 squared square rooted, which is 5. So I've got 5 here and 2 there. So let me just draw that little triangle here. This is 5, again from Pythagoras, and this is 2. So I can get this by doing sine inverse of 2 over 5. But that's not the full thing. I also need this angle here. Let me just use a different color. I need this angle here. Now to get that, I can form another right angle triangle this way. Let's call that angle beta. Now to get beta, just draw it over here. Right, beta, my opposite is 4 and this is 3. Okay, and so I'm going to use tan for this one, and I'm going to use sine for this one. So the max argument, I don't have my calculator with me, but it would be alpha plus beta, which is equal to arc sine, or sine inverse, of 2 over 5 plus tan inverse of 4 over 3. Okay, that's that. Now the next part of the question asked me to find the minimum argument. Now to find the minimum argument, I'm going to consider a different tangent. That tangent is when I first touch the circle as I do this. And again, I get another congruent triangle, a triangle congruent with this one. And this angle is alpha. And what I'm interested in is this bit here, which is actually beta minus alpha. Not alpha plus beta, not beta plus alpha. Again, this angle is beta, and I've got this triangle, and that's alpha, the same as that, because it's a congruent triangle. That's 2 and that's 5. And then I could do beta minus alpha to get that angle there. So what is beta minus alpha? Well, beta minus alpha is tan inverse of 4 over 3 minus sine inverse of 2 over 5. And whatever that is. Okay. Finally, what's the maximum magnitude I can have? Well, that's when my point is furthest away in terms of distance from the origin. Now, that is actually the point that's over here, which goes, if I were to join it to the origin, it's the point which is on the line that goes through the center. Now, that is the radius, which is 2, and that's 5, so it's going to be 5 plus 2, which is 7. So this one here is the distance from the center to the origin, 5, plus the radius length, which is 2, and that gives me 7 units, let's say. And there we go.